Good morning, good afternoon. Hopefully you're watching this in third period. 6.1 through 6.4 review worksheet. I'm just going to go through it and how to answer all the different questions. The first example, they're given both in y-intercept form or slope-intercept form. So y equals mx plus or minus b. So I'm going to first graph my b. The b is where the line crosses my y-intercept. So at -7, so I'm going to go down to -7 and I'm going to put a point. And then I'm going to use my slope of 3 over 1. Remember, anything as a whole number can be placed over 1. The top number is how much I go up or down. If it's positive, I go up, and then I always go to the right 1. So up 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. I could also go down 1, 2, 3, to the left 1. Alright, then I'm going to choose a different color. Try anyway. Oh man, I'm just a little off. Okay, and then I'm going to graph my second one, so -6. This is a blue one, I don't know if you can tell. And then up 2, 1, 2 over 1. Right away I have I hit my other line, so I know right away that that's going to be my intersection point, and that is 1. And then I go down to -4, and I'm done. This one is not, they are not both in. So this one is not in y-intercept form. I need to add that 3x to both sides. So that gets me y equals 3x and then -2. So I'm going to go and I'm going to get this out of the way. So I'm going to go to -2, and then remember up 3 over 1. So up 3 over 1 each time. And then this one I'm going to graph, and I go up to 5. And I go up 3 over 1. 3 over 1. If you notice, gosh. They look parallel. I can also double check. They both have the same slope and different y-intercepts. So there's no solution. Alright, this one's a little trickier. Again, I want to get it to where y is by itself. And right now I have 1/3 y. So I need to get 1 y. And so I need to multiply this by a number so that I don't have the fraction. Well, to get rid of a fraction, you multiply by the denominator. So I'm going to multiply everything by the denominator.
Good afternoon. If you happen to lose your wallet,
Times x is 3x. Okay, 3 times 1/3 is 1y. And then 3 times 4 is 12. So with this one, I want to still get my y by itself, so I need to subtract my 3x from both sides. So my new equation is y equals -3x plus 12. So I'll start with the 12, and is that here? And then my negative down 3 over 1. I'm going to connect the 2 points. Then I'm going to go to this one and graph this one, so I go up to 12, and right away I see that my point is right there, and I go down 3 to the right 1, so it's infinitely many solutions. Infinitely many. Okay, so they had the same slope and the same y-intercept, so it's the same line. Okay, the next one is substitution. Remember, you solve one of your equations for one of your variables. Well, y is solved, or x is solved for. It's 2y minus 2. So in this equation, wherever I see an x, I'm going to put 2y minus 2. And then plus 6. I don't have to put these in parentheses because I don't have anything, no coefficient on x. If there was, I would have to put parentheses and then distribute first. So I want to combine my like terms. So negative 2 and 6 is a positive 4. So 3y equals 2y minus, or plus 4. Subtract my 2y from both sides. I get 1y equals 4. Then I need to take what y is and put it into one of my original equations. So x is equal to 2y. So instead of this y, I'm going to put 4 minus 2. Oh, that didn't either. So I need to, order of operations, say I multiply multiply first. So 4 times 2 is 8 minus 2. So x is equal to 6. So I need to make sure to write mine as an ordered pair, 6, comma, 4. Okay. These two are both y equals, so I'm going to set this equal to this. Or pretty much I'm putting this, what this x or y is equal to, in place of this y.
Hi.
Okay, then I want to get all my like terms on the same side, so I could subtract x. From this side, I would have 1x left plus 9 equals a positive 6. Then I would subtract 9 from both sides, so 1x is equal to a negative 3. Then I can take either one of my original equations and put negative 3 plus 6. So I put it into this one. Negative 3 plus 6 is a positive 3. So I have a negative 3 for my x and a positive 3 for my y. Okay, this one, a little more difficult. I need to choose which variable to get by itself first. So I could take 2x equals y minus 4, and I could add 4 to both sides to get my y by itself. So then I have y equals that 2x plus 4. Remember, those are not like terms, so I can't combine them. So now wherever I chose this one, so I have to take this one down here, so negative 3. Wherever I see y, I'm going to put 2x plus 4. And that equals x minus 5. Okay, I have parentheses, so I need to distribute. So 6x and then plus that negative 4, or just minus, negative 12. And then x minus 5, and then minus x. So I have negative 6, subtract 1x, so negative 7x.
Josh, Jenna, please go to the library. Josh, Jenna.
Okay, minus 12 equals a negative 5. Step by step, showing my work. So I have a negative 7x, and this will be a positive 7. So divide both sides by negative 7. X is equal to a negative 1. So then I need to go to my equation, and every time I see an x, I need to put I can put negative 1 in there. So times negative 1 equals y minus 4. So negative 2 equals y minus 4. Add 4, add 4. So 2 equals y. So my y is equal to 2. Okay, and using elimination, everyone's favorites. So right away I see that I have 2y, 2y. So I need to get 0y. So 2 plus a negative 2 would equal 0y, and that would go away. So I am adding these two. Okay, so 3 plus a negative 1 would equal 2x, and negative 6 plus 10 would equal 4. divide both sides by 2, x equals 2. So then I can go and take my what x is equal to and put it into either one of my original equations. So 3 times 2 plus 2y equals a negative 6. So I have 6 plus 2y equals a negative 6. Minus 6 minus 6. So right away you might say, oh, it's negative 6 and subtract 6, that's 0. No, I have two negative 6's. So I have to combine those, and that's negative 12. Divide by 2, y is equal to negative 6. Okay, in this one, we have to get them so that they have the same coefficient. Well, if I look here, 2 and 5, that does not look fun. I would have to multiply this by 2.5, and then I'd have to multiply everything by 2.5, and I don't want to do that. So I'm going to multiply this by 2. So this is 2x plus 4y equals 18. Okay, now if I want to get these, this is 0, I'm subtracting, so 2 minus 2, 0x, that goes away. Now this is negative 5 minus 4. I like to sometimes write it out like this, negative 5 minus 4. I can also do that, so I have a negative 9y. And then again, negative 27 minus 18. So if they're both negatives and I'm adding them together, I get 45. Divide by 9, negative 9. This is a negative here, right? Negative 45, yep. So y equals positive 5. So I'm going to go in, x plus 2y equals 9. So 10 plus x equals 9. Subtract 10, x equals a negative 1. So I have a negative 1 and 5. Okay. Again, I'm going to multiply this whole one by 2. So I have 6, and I want them to be the same. So plus 10y equals a negative 36. If I add these together, they cancel out, so I have 10x equals a negative 60. So x is equal to negative 6. I'm running out of time. So 3, negative 6. How about I just put this up here? Add that in there. I get 5y equals a 0. A lot of people are like, oh, that can't happen. No, it can. Divide both sides by 5. Divide by 5, divide by 5. 0 divided by anything is 0. So y is equal to 0. So my answer is negative 6, comma 0 is where they would intersect. This gets a lot of people. Don't let it get you. Okay? Now, writing the system, a piggy bank contains 100 coins. Nickels and dimes. Dimes and nickels added together equals 100. Total value is $8.50. So 5 cents times the amount of nickels, 10 cents times the amount of dimes, $8.50. The sum of two numbers is 14. So the first number and the second number is equal to 14. This could be x, this could be y. This doesn't matter, the letters. The sum will be doubled. If one of the numbers is doubled, so 2 times x, the first number, the sum will become 22. What are the numbers? Okay, and then these are really good to know. If two lines have the same y-intercept but different slopes, what can you conclude about the solution of this system? Different slopes right away. Different slopes means the lines will intersect. So therefore, lines will intersect at the y-intercept. It's telling you that they have the same y-intercept, so that point is in both of them. Or on both of those lines. If a system of linear equations has no solutions, what does that tell you about the slopes? Slopes are the same, but the y-intercepts are different. Okay, these two